In this video we're going to go through the solutions to problem sheet 1, question 3 part A. So there's a couple of different parts to this problem, but it's all variations on a theme. So you're told in figures question 3A to D, the thick arrow indicates the direction of the electric field experienced by a charge, and the magnitude of this field is indicated to the right of the arrow. So it looks something like this, and you can see that we've got a field which is acting to the right, and it's got a magnitude of 10 to the 6 volts per meter, and this is 1 times 10 to the 6. If you ever see this, it's just shorthand, so it's a bit less confusing. And what else have we got? It's experienced by a charge, and the charge is indicated by a circle, and then we've got the magnitude of that charge next to it. So let's work through and see what we've got to find. So first up, we're asked to determine the magnitude of the force acting on the charge, and then also find the direction of that force. So how do we go about this? Well, we've got two really important equations that we learnt in lecture 2. We've got the expression for the electric force, which is F is equal to Q1 times Q2 all over 4 pi epsilon naught r squared. And we also have the expression for the electric field strength, which is E. And this is Q1 over 4 pi epsilon naught r squared. And it's worth saying that, these do look very similar. So I'm going to just start inking so we'll see a little bit of what's going on. So there is a lot of commonality here. So basically you can see that these expressions are the same if you ignore the Q2. So if we want to get it, well, we can say that F is equal to E times Q2, and we sometimes see this shortened to F is equal to E times Q, and it's a smaller q just to show that it's slightly different. So here I've got it just written here in a bit more neater fashion, and this all comes back to the fact that the force is equal to the electric field strength times charge Q2. So we're going to use this equation to find the solution. So let's find the magnitude of the force. Well, we know that F is equal to E times Q2, so let's find that. So F is equal to E, and we know E because that's given here. So that's 1 times 10 to the 6 volts per meter times Q2, and we also know what Q2 is because it's just this number here. So that's 1 microcoulomb. So remember, that's 1 times 10, this time to the minus 6. And what this gives us is an answer of force is equal to 1 Newton. Remember your units. Your units are really important. So that's the first part done. We've found the magnitude of the force. As for the direction, well, we can see the direction of the electric field that the force is being subjected to. We mean that the charge is being subjected to, So the charge is positive because it's plus 1 microcoulombs. If you don't see a minus sign, you can assume it's positive by default. That's just standard notation. So what it means is because the charge is positive, it means the force will be in the same direction as the field. And we did this in lecture 2. So if you're uncomfortable with this, please go back and revise your notes. So here's a little bit from the lecture notes. So we've got a positive charge, so I've just said, oh look, it's positive, so let's represent it as a nice red one like we did in the lecture notes. And then we can see that we've got E, which is the electric field, and F, which is the electrostatic force, are both acting in the same direction. So there we go, that's the answer to problem sheet 1, question 3A.